Hi class, I'm sick today, so I'm going to be out. So I put together this video tutorial to help you guys out, but if you need any assistance, just send me an email to osolis@episd.org. Let's see. Why is it not working as well? I guess it's just being itself. So we're looking at line segments. It's part of a line consisting of two endpoints and all the points in between. Of course, we already have this in our notes, so I really don't expect you to go ahead and copy this down. We have the example segment AB and how to name it. We have the little line on top with AB. So let's go ahead and take a look at this right here. We're not going to be doing any constructions till later on this week, but we have this example one. Let me go ahead and get rid of the thing right here because we really don't need that. We don't need the quick check, so we don't want to look at that. Okay. So we're trying to find the distance between point -2 and 6. So right here we have our 6. Let me go ahead and use a highlighter. We're doing this from -2 all the way to 6. Now, of course, we can never have negative distance. It's always going to be a positive number. And when we have a single line like this, and we're doing the number line, we're going ahead and doing the distance between 2 points. We always name the first point after x1, and this is going to be x2. And if we had a vertical line, and we had something similar, -2, and we have +6, this would be our x2, and this one would be our x1. It'd be this almost the same thing. Oh, actually, y2, y1, sorry. This will help us at something else later on, so please keep informed about this. So the distance that we're going to be doing this in context would be x2 minus x1. We always take the absolute value of that because we don't have negative distance. So in this case, we have the absolute value of 6 minus -2. Now remember, it's always a difference. That's always going to be a minus sign. But even when there's a negative, so 6 minus a -2 is going to become a +2, and that's going to be the absolute value of 8. Now you're probably wondering what absolute value means, and that means that it gives you the exact value that it is in positive terms. So 8, the absolute value of +8 is still going to be +8. If it was -8, it would become a +8. So it's always just a positive number. That's what absolute values do. So looking at this, we have P, which is at -3.5, and Q, which is at -2. And of course, -2 becomes our x2. This is our x1. So this is going to be -2 minus -3.5 absolute value, because that's part of the equation for that. This becomes a +3.5, so this becomes 1.5. So it's a distance of 1.5 units. For QR, it's almost the same thing. This is at 2. So at QR, we're looking at this as x1, and this is x2, and that's 2.5. So we have 2.5 minus -2, absolute value. So that just becomes 4.5. We'll look at that a little bit more later. Then we have something called the segment addition postulate. So when we're told that point U is between L and Y, we draw this kind of figure. So we have LY, that's the segment itself, with a point U somewhere in the middle. So now we have a segment called LU. We also have a segment called UY. Then we have the entire segment called LY. So we have these 3 segments. So the 2 smaller segments, when you put them together with glue or whatever, it becomes the length of the longer segment. So we have LU plus UY is equal to LY. So this is the segment addition postulate in a nutshell. We take the 2 smaller segments, add them together, and we get the larger segment. So in this case, we have if B is between A and C. So this is the kind of picture we're going to have. A and C, and B is somewhere in between. And we're told that AB is equal to 7 and AC is equal to 20. What is BC? So we're going to use the segment addition postulate. So AB plus BC is equal to AC. And we just look at what we have here and start substituting. And if we don't have a substitution for one of these segments, we leave it alone. So in this case, AB is 7. BC is not there, so they're not talking about that right now. And AC is equal to 20. And we have BC right here. Now we treat BC as if it was an X or a variable. So then we do the subtraction. And then we got BC is equal to 13. So that means that we have this length 7, we have the length 13 right here, and those 2 lengths combined gives us 20. Just remember, we have all of this. So we have another example here. If B is between A and C, same picture. And so our segment addition postulate is AB plus BC is equal to AC. Well, we have that this is going to be 4 units plus 5 units. Well, that's equal to AC. They want to know what AC is equal to, so that's just 9. So that's 9 units long. Now, this is where the segment addition postulate really comes into play. So this is the same picture, AB, BC, okay? So AB plus BC is equal to AC. So now we just need to go ahead and do substitution property of equality. Oops. AB is going to have X as its substitute plus BC, which is 2X plus 6, and that's equal to 5X minus 14. Now we're going to solve for X, and we're going to solve for these particular segments. So let's see, X plus 2X is 3X plus 6. I'm going to subtract 3x from both sides. Then we're going to add 14 to both sides. Okay, and that gives us 20 equal to 2x. Divide both sides by 2. So 10 is equal to x. Now that I can substitute the x with 10, I got right here that AB is equal to x. Now I substitute x with 10. So AB is equal to 10. So this is 10. Same thing right here. We're told that BC is equal to 2x plus 6. So this is 2 times 10 plus 6. That gives us a total of 26. So BC is equal to 26 units. And that's it. We're done with this. No, sorry. Excuse me, guys. Okay. Now let's go ahead and do another thing right here. We have the Pythagorean theorem. We're going to be using Pythagorean theorem. It's going to help us with a few things. Of course, as a reminder, if we have two legs, that's always going to be our A and B. And of course, we have our hypotenuse, which is our C. So if we go ahead and just do our switch ups, this is equal to D squared. The B squared is going to be 6 squared plus 8 squared. Now, we just do our math. So I'm going to say that that's going to be 64 equal to 36, which is equal to D squared. Oh, plus. It's going to be plus right there, not equal to. Okay, so 64 plus 36 is 100. Then we take the square root of both sides. So that gives us 10 equal to D. This is just a reminder. Now, we have a particular problem right here, and I didn't draw it, so... Okay, so now we're going to explore this real quick. We have 2 points, 4, 4, and negative 4, 2. Now we need to find out what the coordinates are, what the distance between those two coordinates is. Now, if you didn't look at it, this is a triangle. We can make a triangle out of this. So this distance right here, and then we have this distance right here. So we can actually apply the Pythagorean theorem to this, because this is a right triangle, just like the one we were working with up here. So we're going to be applying the Pythagorean theorem. Unfortunately, I'm going to have to just go ahead and go without the color coding on this. So let's call this D, which is our distance. So that's going to be D squared. Now, if you notice, we have A and B, so we need to know what this distance is. So this is going to be our A, and this distance is, this is going to be our B. Now, if we remember our formulas, which were up there, we're actually going to be looking at the distance on a horizontal. And we're given our x coordinates right here. So this becomes our x2, and this becomes x1. So that's the, let me see, 4 minus negative 4, just like that. Well, that gives us 8. And this becomes our y, so we have our y1 right here, and y2 over here on this one. So this is going to become 4 minus negative 2, which gives us, well, that's a positive, which gives us 6. So this would become 6 squared plus 8 squared. Oh, wait a minute, it's the exact same thing as the problem above. Take the square root, that's 10, equal to D. Only got 2 minutes left, guys, so we're going to be talking about this as and real quick. So I'm going to replace this part with this right here. So this was x2 minus x1 squared plus y2 minus y1 squared equal to, let me see, D, which we have the square root of that. And that will give us our distance. And that's actually our distance formula in a nutshell. So if we take a look at this particular problem right here, we have these two distant points, and we're going to find the distance between them. So we have 2, negative 1. Always have to write them vertically. Negative 2, negative 1. So these are my x's. These are my y's, and this is the first point and the second point. Now I have D is equal to, let's see, our x1 is going to be 2 minus negative 2 squared plus 1 minus negative 1, or negative 1 minus negative 1 squared. This becomes positive. This one also becomes positive. So this is 4 squared. Take the square root. Plus, well, that's going to be negative 1 plus 1. That's 0 squared. That leaves me with D equal to the square root of 16, because this is 0, of course, and that's going to be 16. And D is equal to 4. So the distance between these two is 4 units. And that's the distance formula in a nutshell. I'll go into more detail later, but that's the basic stuff. So thank you, guys. We're going to be talking about more of this later on. See ya.